Hello, everybody. It's Professor Ken, and I'm here in the jungle with my friend. Um, anyway, as promised, I'm going to make a video to show you how to do 3 different types of null hypothesis tests. And if you happen to know Emma DeSanti or Kayla Castro, you can thank them because they put the pressure on me to make this video. I probably wouldn't have done it without their encouragement. So you owe them a debt of gratitude. All right, let me share my screen. Okay, and I have this great, 3 great problems. So problem number 1, the length of IV tubing must have a mean of 3 feet and a standard deviation of 0.08 feet. A sample of 10 IV tubes were tested with the following results. All right, there they are. Now, test with a confidence level of 0.05 to see if the claim that the mean tubing length is equal to 3 feet. Okay, so the first thing we're going to go do is go into Desmos and look for the null hypothesis test for means and find out what the mean of our sample is and what the standard deviation of our sample is. Okay, let's go to Desmos. Oh, let's learn together. Null hypothesis test with mean. There it is. I'm going to open the graph. Okay, now we're actually testing the mean to see if it's equal to 3.0. So it's going to be a two-tailed test. So I'm going to go negative t and positive t. Let me see what the confidence interval is. It's 0.05. So that means I'm going to let this equal 0.05, but I'm going to subtract a over 2. So there we have two tails. Okay, our n value was equal to 10. And the mean, the claim of the mean that the population mean is 3. And we have to still calculate the mean and the standard deviation to find our t. All right, but okay, let me just, there it is. Okay. So let me make sure we have the right area. 0.95, yes, that's the right area. Okay, so what we have to do here is I'm going to go to my keyboard and I'm going to go to functions and I'm going to go to statistics and we're going to find the mean. And I have to type in my values there. And unfortunately, they don't cut and paste very well. So 2.87, 2.56, 2.87, comma, 2.56, comma. They're not in the parentheses. Oh, good Lord. But now they are. Okay, let's keep going. Won't take that long. 3.02, 2.75. 3.02, comma, 2.75, comma. All right, 2.64, 2.89. 2.64, comma, 2.89, comma. Okay. 3.22, 3.01. 3.22, comma, 3.01. 2.93, 2.56. 2.93, comma, 2.56. So the mean of our sample is 2.845. Now we have to find the standard deviation. Okay, and we're going to use the same data, so I'm going to copy it. Paste it. 0.22. So 2.85 and 2.85 is the mean. So let's go over here. Go right here and do a page, insert a page break. So I have all this room. All right, so I'm going to go to draw and I'm going to use this pen. Okay, so what do we know? We know our sample mean is equal to a number that I forgot. 2.85. And we know our sample standard deviation is equal to 0.22. Our confidence level, get the rest of that from up here, is, okay, test with 0.05. So alpha equals 0.05. And since the claim is equal to, it's going to be a two-tailed t-test. All right, so I do believe we have enough. Oh, and the mean claim is equal to 3.0. Now, if the company making the tubing claims the mean is 3.0 and charges it that way, but really only has the mean 2.85, they could be gypping the hospitals. So that's why such a test is kind of important. Okay, so there's our information. So the claim, the null hypothesis is that the mean is equal to 3.0. And the alternative hypothesis, oh, that's a 2, that's a 3. The alternative hypothesis is that the mean is not equal to 3.0. And our alpha level is equal, look, it looks like a fish, the alpha is equal to 0.05. So now for steps 5 and 6, we have to draw the picture. So I'm going to insert another page break. All right. So I'm going to draw my T graph. Hey. So this is T. This is X bar. Here we have 0. Here we have 3. All right, and it's a two-tailed test with 95. So this is going to be 0.025. And this is going to be 0.025. Just want to make sure I got that correct. Yes, 0.05 significance. So that's 0.95. And we need to find our critical t-value. So let's go back. And we just want to make sure that this area is 0.95. And it is. So our critical t-value is 2.26. Oh, I forgot to put my mean in here that we calculated. The mean that we calculated is 2.845. And the standard deviation, I believe, was 0.22. All right. So our critical t-value is 2.26. So we have a 2.26 here and a negative 2.26 here. All right. And our t statistic that we're going to be testing is our big old T is negative 2.23. Oh, they just barely got away with it. Negative 2.23. Okay, so we're going to reject the null hypothesis if T is less than negative 2.26 or T is greater than positive 2.26. And then we're going to fail to reject if negative 2.26 is less than T, which is less than 2.26. All right, step 8. Oh my goodness, the big T value is negative 2.23. Oh, these bastards got away with it. So we failed to reject. Therefore, failed to reject. Now let's go look at our alternative hypothesis because our statement has to be based on that. Okay, so the alternative hypothesis is that the mean is not equal to 3. So we did not prove that the mean is not equal to 3. So let's do it. Insert a text box. Oh, that's not a text box. Draw a text box. So step 9, there is not enough evidence to prove that the mean length of IV tubing is not 3.0 feet, say. Okay, but man, they just got away with it by the skin of their teeth. Okay, so let's go to problem number 2 now. We'll insert a page break. Okay, now at this time, let's go to draw. Okay, what are we testing? The same data from problem 1. So that means, but we're only testing the standard deviation. So the standard deviation of our sample was equal to was it 0.22? Yes, 0.22. And the claim is that it's 0.08. So the claim of the standard deviation is 0.08. And we know that I got this thing in my way. I need to move it up. Okay. And we know that n is equal to 10 because there were 10 samples. And alpha this time is 0.10 because it's 90% confidence level. All right. So that's number 1. So 2, I think I could do it with, I like doing it with the text boxes. It's a little easier for me. So step 2. The null hypothesis is that the standard deviation is equal to 0.08 feet. So I gotta find that symbol. There's alpha. Oh, there it is. Okay. Equals 0.08. Okay. Now I'm going to take this box and I'm going to paste it again. And now for step 3, I'm going to say the alternative hypothesis. Oh, I like this much better. Is that sigma is less than 0.08. And if it is, that company going to be in trouble. Oh, no, their claim. They want it. Their claim is that it has to be less than, that's their claim. If it doesn't work, then they're in trouble. All right. So now step 4, I'm going to insert a text box. Step 4, we have to set our alpha level. So alpha, so let me insert that alpha letter. Where the heck is it? I gotta drop this down to find it. There it is. Alpha is equal to 0.10. Okay, so now we're ready to do steps 4, 5, and 6. And I'm going to go to draw. Okay, so we're going to make, now the distribution is a chi-square distribution. So we'll make the roller coaster hill unless we're landing, and then it is a whale. There's chi-square. There's S. Here's 0. There's 0.08. Now it's a one-tailed test because it's less than. So the area here is going to be 0.10, and the area here is going to be 0.90. All right, let's go to the Excel. Using null hypothesis with chi-square. Oh, standard EBS. Okay, so what do we know? We know n was equal to 10. The standard deviation of our test was S, 0.22, and the claim was 0.08. So this is 0.22. This is 0.08. Now it's a left-tailed test, so R alpha is going to be 0, and left alpha is going to be 0.10. So the left critical value is 4.16, 4.17. That's 4.17. All right, and our chi-square that we're testing was equal to 68.1. Let me go over here and insert a page break because I'm not done yet. Insert the old page break. Okay. So now we're ready for part 7, which again, I'll do with a text box because that seemed to work pretty well for me. So for number 7, we could say to reject the null hypothesis if 4.17, no, if chi-square, I'll just do it like that, is less than 4.17, and fail to reject if the chi-square is greater than 4.17. All right, I'm going to stay in the same text box and do step 8. What do we know? The chi-square, I feel guilty. Let me insert it. Go to insert, hang on. Insert, oh, there it is, equation. And I'm going to do one of these. And I'm going to find my little Greek letter chi-square. So let me go to Greek. There it is. So in this little tiny box, I have to have the chi. Where the hell did it go? There it is, chi squared. Okay, I'm going to copy that. Let me put it here. And let me put it here because I feel guilty. Okay. Okay, so chi square is equal to, let's look up again at our table, 68.1. Wow, we smashed it. 68.1. So therefore, we're going to reject the null hypothesis, which is also called 12. All right, so now we're going to insert one last, I can just keep it, I guess. If I pull this down, make it a little bigger. Okay, step 9, what do we conclude? That, let's look at our alternative hypothesis, that so we're going to conclude that not only, since it was way over here, we're going to reject the null hypothesis. And really what we can say is that the standard deviation is greater than 0.08. All right, because it didn't fall in there. So well, actually, oh, I'm sorry. So we're actually, let's go back here. It says we reject the null hypothesis of chi-squared is less than 4.18. Chi-squared is equal to 68.41, so we fail to reject. So now what does this mean? It means there is sufficient, or we could say we cannot prove that chi-square is less than 0.08 feet. So the claim made by the IV tubing company is false. I love that. All right. So there's the second problem. Now let's go to the third problem about the potholes. All right. So what do we know? We know that N is equal to 200. So of the 200, 27 blew out their tire. So P hat is equal to 27 over 200. Test the claim, and alpha is equal to 0.01. Test the claim that fewer than 5% of drivers will blow out their tires. So they're claiming that P is equal to 0.05. And it's a one tail, it's a left tail Z test. All right. This is all part one. Part two. The null hypothesis is that P is equal to 0.05. And the alternative hypothesis is that P is less than 0.05. So alpha is 0.01. All right, 5 and 6. Let's draw the picture. So this is Z. This is P. This would be 0. This would be 0.05. And since it's a left tail test, we only have to make that left tail. The area of the left tail alpha is alpha 0.01 or 0.10. Alpha is 0.01. Okay. So this is 0.01 here, and this is 0.99. So we need this critical value of for Z, which would be right here, and it is going to be negative. So let's go to the Desmos. And now we're going to do null hypothesis with, look at all those for the mean, with proportion. Open that. Okay. So it's normal distribution and it's left tail. So we're going to have negative Z over here and infinity over here. Our alpha level is 0.01. So it says alpha over 2, but since it's just, oh my gosh, Control Z. Since it's just one tail, we're going to get rid of the divided by 2 part. All right, so now there's our tail. Our shaded area is 0.99. It's exactly what we want. Okay, here's P hat. P hat was equal to P hat, 27 over 200. $27 over 200. And the claim was that it was 0.05. All right. And the sample size was 200. So our Z statistic is 5.5. All right. So our critical Z value is 2.32, but it's really negative 2.32. So it's negative 2.32. And what's the Z value we calculated from P hat? The Z value we calculated from P hat is equal to 5.5. So now we're able to do step 7, and I like those text boxes again. So for step 7, reject the null hypothesis if z is less than negative 2.32. Fail to reject the null hypothesis if z is greater than 2.32. All right, so what's our decision? Z equals 5.5. Therefore, fail to reject. So we're not, okay, so the claim is that the percentage of people who blow out their tires is less than 5%. Our data does not support that. So 9, our evidence does not support that fewer than 5% of tires get blown out by the pothole. The claim is false. And there we have it. Okay, so I'm going to stop my share. So I have shown you how to do our 3 types of null hypothesis tests that we've learned, but only 2 of them, the one with the mean and the one with the proportion, are going to be on the quiz. All right, I don't know how long I've been recording for, but probably less than 30 minutes, and you're going to have 10 minutes per problem. So for me to explain it in that amount of time certainly means that you could do it without explaining it. I mean, not explaining to an audience recording. So this is Professor Ken. I'm signing off. Have a lovely night, everybody.